Today we read about types of functions. First, identity function. A real valued function f maps from real set to real set is said to be an identity function if this f is defined by y equal to f of x, that is equal to x for all x in the real set R. For example, f of 1 equal to 1. If we put x equal to 1, our image will be 1. F of 1 equal to 1. F of 2 equal to 2, and so on. Come to the Venn diagram. This is our real set. This is our real set. This real set is taken as domain, and this real set taken as codomain. Here, f of 0 is 0. F of 1 is 1, f of 2 is 2, and so on. F of minus 1 is minus 1, f of minus 2 is minus 2. Here, domain of f equal to the real set. Range of f is equal to real set, also codomain. If we take any fractional number also, the fractional number we can get an image. The graph is a straight line like this. This is our x-axis, it is our y-axis. Here is a 1, f of 1 is 1. F of 2 is this 2. 1 and 2, this will be 2, 2, 1, 1, and that is 0. This is 0. If we join these points, we can get a straight line. So this straight line like above. So identity function just like a straight line, making an angle 45 degree with x-axis, and it appears in the first quadrant and the third quadrant. Come to constant function. Define the function f from R to R by y equal to f of x equal to c, where x is a real number, where c is a constant, and each x in R. Here domain of f is the real set and its range is a singleton set. Therefore, f of 1, if we take x equal to 1, f of 1 equal to c. If we take x equal to 2, f of 2 equal to c, f of 3 equal to c, and so on. Its graph is, we take the graph, we consider a plane, x-axis and y-axis. It is our origin, and taken the units 1, 2, 3 towards right, and 1, 2, 3 similarly towards upward. 1, 2. The line is parallel to x-axis. Here is my line. It is line parallel to x-axis. Here domain of f is real set and its range is a constant, that is singleton set C. Come to the polynomial function. A function f maps from real set to real set is said to be a polynomial function if for each x in R, y equal to f of x, y equal to f of x equal to a0, a1x plus a2x square plus dot 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 plus an x to the power n, where this n is a non-negative integer and a0, a1, a2, a3, an are the real numbers. For example, f of x equal to x cube minus x square plus 5. G of x equal to x to the power 4 plus 1. These are the polynomials. These are the polynomial function. But h of x equal to x to the power 3 by 2 plus 2x plus 4 is not a polynomial function, since the index or degree 3 by 2 is not an integer, because here we told where n is a non-negative integer. Here n is a non-negative integer, but here n is a 3 by 2. n is 3 by 2. So 3 by 2 is not an integer, it is a fractional number. So it is h of x is not a polynomial function. Now come to fourth function, that is rational function. Rational functions are functions of the type fx by g of x, f of x by g of x, where f of x and g of x are polynomial function of x defined in a domain where g of x is not equal to 0. this g of x should not be 0. Come to an example. Define the real valued function f maps from real set difference 0 to real set defined by f of x equal to 1 by x. X is an element of r difference 0. Here we see that we have x and fx. X, if we put x here 1 by x, my f of x obtained. The x should not be 0. That's why I took 0.1. If I put here 0.1, this will be 10. If I put 0.2, this will be 5. If I put 0.4, this will be 2.5. And 0.5 to 1, 1 and 2, 1 by 2, that means 0.5. Similarly, if we go to negative side, minus 0.1, this will be minus 10. Minus 0.2, it will be minus 5. Minus 0.4, this will be minus 0.25. Minus 1, minus 1, minus 2, minus 0.5. In this way, we can draw a graph. Now, look at the graph. As per this tabulation, I drawn the graph. My x-axis, y-axis, 1, 2, 3, right to the x-axis and towards upward 1, 2 on along y-axis, minus 1, minus 2 towards left of x-axis and downward minus 1, minus 2. Using the 0.1, 0.2, 0.4, minus 0.1, minus 0.2, minus 0.4, minus 1, minus 2, I draw my graph. This is my rational function. My rational function f of x equal to 1 by x. This is my function. Come to the modulus function. A function f from real set to real positive is defined by f of x equal to absolute of x. For x is a real number, is called a modulus function. Here f of x equal to modulus of x. This symbol is known for modulus symbol and modulus of x. We define by x if x is greater than or equal to 0. Minus x if x is less than 0. Now come to the example. F of 2 equal to 2 modulus. That is 2. Because 2 is a positive quantity, so it is only be 2. And f of minus 2, we have minus of minus x if x is less than 0. X is negative number, then we put here minus sign before x. So minus 2, f of minus 2 is minus of minus 2 equal to 2. Similarly, f of minus 0.3 equal to minus of minus 0.3. It is 0.3. If we plot the graph, x 0, f of x modulus of x is 0. 1 modulus of 1 is 1. 2 f of 2 is 2. 3 modulus of 3 is 3. 4 modulus of 4 is 4. Minus 1 modulus of minus 1 is plus 1. Minus 2 modulus of 2 is plus 2 in this manner. So we can draw the graph. This is my x-axis. This is my y-axis. This is my origin. This is the graph. 1, 1 first quadrant, 2, 2, 3, 3. This is in first quadrant and second quadrant. My y equal to modulus of x. Now come to the signum function. A function f maps from real set to real set is defined by f of x equal to 1 if x is positive, 0 if x equal to 0, minus 1 if x is less than 0. And in this concept can be expressed in a formulae: x by modulus of x if x is non-zero, 0 if x equal to 0, is called signum function, and its domain is the real set. The range set is -1, 0, 1. Come to the picture. X-axis, y-axis, origin, and this value is -1 towards downward along y-axis, 1 along. so upward along y axis. So y equal to +1 is towards right and y equal to -1 towards left. So this is the picture of signum function. The greatest integer function, a function f from real set to real set is said to be greatest integer function if it is defined by f of x equal to bracket of x. In another sense we say bracket of x, where x is a real number. If the f of x equal to -1, this -1 and 0, in between -1 and 0 the value of x is there, the lowest value -1, the greatest integer, the integer value not greater than the value of x. 0 if x lying between 0 and 1. N, f of x equal to n if x lying between n and n plus 1, where n is an integer number. Now come to the example f of 1.2. 1.2 its integer is 1, as because this 1.2 is lying between 1 and 2. Similarly f of -1.2. So -1.2 is the bracket of -1.2, how much? This will be -2, as -1.2 as -1.2 lying between -2 and -1. Come to its graph. We have tabulated x fx. X is equal to 0, f of x equal to 0, bracket of 0 is 0. X equal to 0.1, bracket of 0.1 is 0, because 0.1 is lying between 0 and 1. So we write 0. 0.9, 0, 1, 1, 1.1, 1, 1.9, 1, 2, 2. Similarly -1, -0.1, -1, -0.9, -1, -1, -1, -1.2, -2. In this way we draw the graph. 0, that means 0. 0 to 1.9, this is 1.9. 1.9, that will be 0. Similarly, if we took 1 here, 1, 2, 3, 1, 2, 3, -1, -2, -3. It is a -1, -2, -3. If we took like this in this form, so this is the graph y equal to bracket of x, or greatest integer of x. Some authors, in mathematics we go through different examples. We said this function just like jump function, staircase function, post office function also.